Hello learners, welcome back to our YouTube channel Quick Learners with Shannon Mush. I am Soban Raza, faculty of VLSI Design and Embedded System. Today I have come up with a special concept called as Shannon's Expansion Theorem, which is an important theorem in Boolean algebra. So now we will look into this Shannon Expansion Theorem. So basically, while solving our Boolean algebraic functions, we have a lot of larger functions which can create complexity. So by this Shannon's expansion theorem, we can break these larger functions into smaller functions, and hence therefore this expansion theorem is given by Shannon's, hence the name Shannon's expansion theorem. So we can have this larger functions in this form given as f equals to a of f equals to 0 plus a dash f equals to 1. So we have to get our function in this form, that is a f equals to 1 plus a dash f equals to 0. So let's consider a random example so that we can get our function in this form. We can have f equals to a dot b plus a dash dot bc plus ac. So we can convert this function into this form, that is given by f equals to a of b dot c plus a dash of bc. Hence we have got a larger function in this form. Now a Shannon's expansion theorem can be written as f equals to a dot b plus b dot dash c plus d. Therefore, this function can be implemented using three different types of mux, which can be shown as so. This is our mux representation of our Shannon's expansion theorem. The advantages of this Shannon's expansion theorem are: this particular theorem can help us to reduce the complexity of our algebraic function. It is very useful in different types of algebraic functions. So, thank you.